use the arrows.
Okay. Yes. So I want to talk a little bit about something funny I discovered about the fold operation. Am I going 15 seconds? So quickly, fold is an operator that appears in many functional languages and otherwise. It's called reduce in Common Lisp. It's basically an operator that takes a binary operator like plus, times, intersection, and expands it into a unary operator. So you can fold a binary operator over a set, or over some normally ordered sequence. We normally assume that the complexity of the operation is constant, so the fold becomes a linear time operator. But I took a look at some cases when the complexity is not constant, when the complexity increases as the fold progresses. And one example of that is if you want to add up a sequence of rational numbers. If you just add simply from left to right, the denominator, left to right, yes, the denominator becomes very big very quickly. So you allocate large objects very quickly. And so sometimes there are smarter ways to group the operators in order to hopefully give a less memory intensive computation. So if we advance this computation as I've shown here, we compute fairly small denominators until close to the end, and then we start computing large denominators. So my question was, is this faster? And on what types of problems might this technique be better than just a left to right fold? Yes. So the complexity of the addition operation of rational numbers is cubic as a function of the number of digits you compute. So a linear left to right fold, I computed the sum of these cubes to be 8,700, and using the second technique I just showed called a tree fold, you get something like 2,700. So hopefully the experimental data will match this. It turns out that it does for these situations. The type of fold I want to implement is something like this. I traverse along the input, the x values, I combine pairs, and then I have a pair of results that I can combine into this result 3. At that point, I can release these intermediate results 1 and 2, so they no longer are taking up heap space. Keep going, 5, 6, 7, 8, then I can combine 4 and 5, 6, and then I can combine those two to get a larger result. And then at the end, because you may not have a power of 2 number of inputs, you have some leftovers you have to deal with somehow. Okay. So the code has to have 3 parts: something that consumes the input sequence, something that dwindles this tree, that's what I call it, dwindling the tree, and then something to handle the leftovers. There's the code in Scala. So you have this consumption part, the dwindle tree part, and then the do the rest part. You have this is the code in Common Lisp, and I wrote this one first, so I could probably redo this and make it a bit smaller. But the code is larger than I would like for it to be. One of the reasons is I'm having to do a lot of work, a lot of lines of code to manage this tree dwindling. Okay, which is really orthogonal to the fact that I want to apply this operation left to right way. I showed this to some well, this is the same code in Clojure. I showed this to some Haskell developers, and I know almost nothing about Haskell, and they tried to convince me this would be easier in Haskell. And when they finally convinced me of what's happening there, then it became very clear what to do, and I rewrote the code in Clojure, and it's very small. And the reason it works is because the map and the partition, so partition takes a sequence and lazily computes a sequence of pairs, and then if there's an odd number of them, attaches this sequence to the end. So I put the unit at the end, so it's always a set of a sequence of pairs. And then map is also lazy. So you map lazily this plus operator over a lazily generated sequence of pairs, and you get exactly the same semantics as you had in Haskell. And a comment I made was, that's actually pretty difficult to do in Common Lisp. Because in Clojure, you have these functions that implicitly, the language is not lazy like Haskell is, but you have a lot of functions that give you this lazy ability. So I think there probably are some lazy libraries in Common Lisp that you could probably do the same thing with the library. Anyway, I found it interesting. I commented on this in a paper that I submitted, that I said this Clojure code was inspired by Haskell code, and the reviewers responded, no, it's not. That's all.